So today we're going to start Chapter 5, Section 4. This will not be on the quiz on Wednesday. However, it will be on the test next week on Thursday. So for exponential equations, if the equation that is given to you is exponential, then all we would have to do is do the change of base, make the bases the same, and use the one-to-one property, and then set the exponents equal to each other. Now, the other thing is, if e is on one side of the equation, what we'll do is take the natural log of both sides of the equation. If the bases can't be changed to the same, then we'll convert the exponential to log, and then we'll use the change of base, and we'll use our calculator. Now, on the quiz, even though I showed you in 5.3 the change of base, all the questions on the quiz will be without a calculator. There will more than likely be a calculator portion on the test, which will be next week. So remember, if the equation that's given to you is in exponential form and you can't solve it, convert it to log. If it's in log form and you can't solve it, try converting it to exponential. So for example, let's say I gave you something like 5 with the power of x equals 25. This is back when we first learned about exponential and doing the one-to-one property. I can solve for x by changing the 25 so it has the same base. I could change this to a 5 squared. And now the bases are the same. Get rid of the 5 and x equals 2. However, if you were given something like 5 raised to the x power equals 35, I can't change 35 so it has a base of 5. So this would be an example where I would turn it into log form and then I would use my calculator. So for example, I can't change 35, so instead I can do my bay trick. So remember, when it's in exponential form, it's spelling B, but when I go to log, I'm going to be putting it in as bay. So this will become log base 5 of 35 equals x. So you would get out your handy dandy calculator, and if you have the newer calculator, remember and then you're gonna scroll down on my calculator. It's option A, and it has the word log base, and then it would open up log with a little box and another little box, and then you would fill in the 5 and the 35, hit enter, and it'll give you the answer. If you have the older calculator, you're going to use the change of base and be able to recognize the change of base on the non-calculator quiz. I may give you a question like this, but I just may ask you to put it into the ratio. So if that were a question on the quiz next week, or on Wednesday, sorry, all you would do is tell me that it's log of the big font divided by log of the little font. Now, I know last week when Mr. Pearl taught you this, he told you it was like the number that was raised up a little bit higher goes in the numerator, and then the one that's lower. I think of this as being a bigger font. The 35 looks like it's a larger font than the 5. So I do log of big font divided by log of little font. And then you would just leave it like this if you weren't using a calculator. But in the homework, you're going to round to whatever place they say. Most of the time it's 3 decimal places. So once you do either this method or this method, then you're going to get 2.209. And that would be your answer for this one. So again, in exponential form, we can't solve it, but we could turn it into log form and we could solve it using our calculator. Now, all the examples we're going to do moving forward are going to use everything we've learned so far in Chapter 5. We're either going to turn it into exponential, use the one-to-one property, change the base, get rid of the bases, set the exponents equal to each other, turn it to log form and use all those properties, or natural log. When you're learning this section by section, everything's fine and wonderful. But then now, when you have to combine all of your knowledge and try to figure out, what do I do? Do I use 5-1s? Do I use 5-2? Do I use what I learned in 5-3? So this is where you have to critically look at the problem and figure out, what do I need to do? So let's look at the first example. First example is nice and easy. Notice, don't get afraid that it's got a base of e. Notice both sides of the equation have the same base. So all we do is get rid of the e's. And then we're going to set the exponents equal to each other. So get rid of the base. And now I'm going to set negative x squared equal to negative 3x minus 4. Now, notice we've got an x squared, so this is a clue that we're going to be factoring. Whenever you're trying to factor a quadratic, try to keep your x squared term positive. So instead of adding the 3x and the 4, I'm going to add the x squared. And remember, what we're doing here is setting our equation equal to 0. And now I need to find my values of x. So I'm looking for two numbers that will multiply to give me negative 4. That will add to give me negative 3. So those two numbers are going to be negative 4 and positive 1. And now you set each of the factors equal to 0 and solve for x. So I'll add 4, x equals 4, subtract 1, x equals negative 1. So we're using our one-to-one property here, okay? Now, what we're going to see coming up, if your equation that's given to you to solve for the variable is in exponential form, we don't need to check our answers. But when the given problem is in log form, remember, we can never have a negative base, and we can never find the log of a negative number. So if it makes either of those two parts a negative, we'll get rid of our answers. Now, this one was already in exponential form, so there's no check here. So the two answers are positive 4 and negative 1. Let's try number 2. Exactly the same thing. Notice I can just apply my one-to-one property. The bases are the same. Get rid of the e's. Set the exponents equal to each other. And again, solve for x. Again, it's quadratic. I've got an x squared. So I need to get all my terms together and set it equal to 0. And now I'm looking for factors of negative 8 that will give me negative 2 when I combine them. Those factors are going to be x negative 4 and positive 2. Set the two factors equal to 0 and solve for x. So I add 4 on this one. X equals positive 4 and x equals negative 2. And again, no check here because the original problem was exponential. Let's try the next one. Now, the next two are actually calculator questions. So if you have your calculator, go ahead and take them out. So I'm going to go ahead and... All right, so number 3, it's given to us in exponential form. I need to isolate the exponent, the base with the exponent. So I'm going to divide both sides by 3. And then I'm left with 2 raised to the x power equals 14. Now, I cannot change 14, so it has a base of 2. So I cannot solve this in exponential form. So now what I'm going to do is change it into log form, and I'm going to go ahead and use my calculator. So again, right now, remember, it's spelling B-E-A. So I'm going to move it to log. So log base 2 of 14 equals x. I'm spelling bay now. So on your calculator, you're either going to hit that math button and do the log base or do the change of base. Now, if this were a question on the quiz on Wednesday, then showing this with change of base, you would do log of big font over log of little font equals X. So on the quiz, if it says to write this as a change of base ratio, this would be the answer without your calculator. However, if you were using your calculator, you would do log of 14 divided by log of 2. Once you do this on your calculator, you're going to get 3.807, and I'm going to show you on my calculator. So number 4 is also a calculator question. Again, I'm going to isolate the 5 to the x, so I'm going to divide both sides by 2, and I get 5 to the x power equals 16. Again, I cannot solve this exponentially. I can't change 16 so it has a base of 5, so I'm going to convert it to log. So it's going to be log base 5 of 16 equals x. So this is what you're going to enter into your calculator. Now, again, if on the quiz on Wednesday, it says to show me the ratio, you're going to do log of big font divided by log of little font. And that's going to give you your answer. You would do those, divide them. Or, again, you would hit your math button, scroll down, get that log base. Once you hit enter here, x is equal to 1.723. So for number 5, I'm going to go ahead and I'm going to isolate e to the x first. I'm going to get this into exponential form. So I'm going to subtract 5 from both sides. And now I have e to the x equals 55. So now at this point, I can't solve this. I can't change 55 to a base e, so I'm going to change it into log form. Now, you can either choose to put it into log or natural log. If you do natural log, the base is always e. So that's the easier way to do it. So again, right now, this is spelling B-E-A. So I'm going to go ahead and put it into natural log, and I'm going to spell bay. So I'm going to do ln. Remember, this e is assumed here. And then we put the answer, which is 55, equals x. So when you put it into the natural log, all you're doing is hitting the ln button. It'll open the parentheses, and then you enter 55, close the parenthesis, and hit enter. Rounded to 3 decimal places, 4.007. So again, all you're doing is touching the ln button. It'll open the parentheses, put 55, close the parenthesis, hit enter, and then you get a crazy long decimal, rounded to 3 decimal places, 4.007. For number 6, I'm going to isolate the e to the x power. I need to add 7 to both sides. E to the x power equals 30. Again, I cannot change 30 so it turns into an e with that base. So I'm going to, again, turn it into log. Now, technically, I could do this. I could do log base e of 30 equals x. But then I'd have to do the change of base. So it's a lot easier when it has a base of e to turn this into ln. So ln of 30 equals x, because the base of the natural log is the e. If you were to hit the log button, its base is a 10. So here, rounded to 3 decimal places, 3.401. For number 7, again, I want to isolate the exponent. So I'm using my Algebra 1 skills here. I'm going to first add 4 to both sides. And then I get 2 times 3 raised to the 2x minus 5 power. equals 15. Divide by 2. And now my exponent is isolated. I'm going to leave it a fraction. Now, I cannot make these bases the same, so I'm going to convert it to log. And again, it's a calculator question. So this time I don't have a base of e, so I'm going to go ahead and do log. So I'm going to be doing log base 3, 15 divided by 2 equals 2x minus 5. Now, this part right here is a calculator part. You're going to evaluate log base 3 of 15 over 2. You could make it 7.5. When you do this, do not round until the end. So you're going to leave the really long number that you're going to get from this and leave it on your calculator. So let me show you what you're going to get. Okay, so if you don't have the newer calculator, what you're going to do for this red part is you're going to do log of big font divided by log of little font, or use your log base on the newer calculator. This is going to give me 1.834043767, and it's now equal to 2x minus 5. Do not round this to 1.8. You will get it wrong on WebAssign. You need to leave the long number on your calculator. So now what we need to do is isolate. Use our Algebra 1 skills. We're adding 5 to both sides. And again, you can do this continuous in your calculator. So you're going to end up with 6.834043767 equals 2x. You're dividing both sides by 2. And then now is when we round, after we divide it by 2. So after you divide, you get 3.417021884. Rounded to 3 decimal places is just going to be x is equal to 3.417. So again, when you're doing the WebAssign for this, if you read up at the top, it's either going to tell you not using a calculator, or as soon as you see rounded 3 decimal places, that's a clue that in the problem, you're going to be using your calculator. Let's try number 8. Same thing. We're going to isolate the exponent. So we're going to subtract 4. And then I get 6 times 2 raised to the x plus 5 power equals 7. Divide by 6. 2 raised to the x plus 5 power equals 7 over 6. Again, I cannot solve this the way it's given in exponential form now, so I need to convert it to log. So I'm going to be doing log base 2 of 7 over 6 equals the x plus 5. So again, this is calculator. Do not round until the end. So we're going to leave the super long number we get from our calculator. We're going to leave it on there. So if I go ahead and calculate this number, I end up with 0.22239242213 equals x plus 5. And now to isolate x, all I have to do is subtract 5. And you end up with negative 4.777607579. Rounded to 3 decimal places. This 7 looks at the 6 and it tells it you're rounding up. So negative 4.778. So, okay, so these next 4 examples, these are going to get really complicated. Now, my advice to you is write as neat as possible because it's going to get really messy. All right, so here we go with number 9. I'm going to go ahead and go over here to the side. Now, notice here, this is a 0.4 that's in the problem here. So number 9, it's in exponential form. I can't change the base. So this is the technique where we're going to add log to both sides. Now, it doesn't matter if you add ln or log, you get the same answer either way. I'm going to add ln to both sides, one less letter. So I'm going to go ahead and I'm going to put ln, and then it's going to be 3 2x minus 1 equals ln, and this is 0.4. I'll put a 0.4 so we don't forget that there's a decimal point here. Okay, so this is one of the techniques where if you can't condense or do anything, you can also add either log to both sides or the natural log. Now I'm going to apply my power property, and I'm going to move the exponent down in front of the ln. So I'm going to take both of these powers and pull them in the front. So now I'm left with 2x minus 1 times ln of 3 equals x plus 2 times ln. Again, it's 0.4. Now, this ln of 0.4 or 0.4 is just a number. Same thing with the ln of 3. Now what I need to do is apply my distributive property. So I need to distribute the ln 3 to the 2x and to the negative 1. Same thing on this side. So I'm going to end up with 2x times ln 3 minus, and then negative 1 times ln 3 is just ln 3. Distribute on the other side as well. I end up with x times ln 0.4, and then do it in black so it shows up when I go here, and then 2 times ln of 0.4. I need to get my like terms together. So I want to get my x's together and my constants together. So these are my x terms that I'm going to get together. And then these are going to be my constants that I'm going to move together. So what I need to do is add. I can add or subtract. Let's move the x's together first. So I'm going to subtract x ln of 0.4 from both sides. And now I have 2x ln 3 minus x ln of 0.4. Now I still have the minus ln 3 here. And then on the other side, I still have the 2 ln 0.4. Now I need to move this ln 3 to the other side by adding it. So now I have 2x ln 3 minus x ln of 0.4 equals 2 ln 0.4 plus ln 3. Now I can factor out a GCF of the left side. So my GCF is x. And now I'm left with 2 ln 3 minus ln 0.4. This side is staying the same. 2 ln 0.4 plus ln 3. And now all you're going to do is divide both sides by 2 ln 3 minus ln 0.4, 2 ln 3 minus ln 0.4. So this will be calculator now. So this would cancel. And now you'll be left with x is equal to, rounded to do 4 decimal places. So what you're going to do is you get negative 0.2357. Now, when you're doing this on your calculator, you're going to need to put parentheses around the numerator and then parentheses around the denominator. And then once you divide this divided by this, that's the decimal you should be getting. Again, be careful. Remember, it's a 0.4, not a 4.